Okay, to finish up this lesson, we just have two properties to look at. The first one being our inverse properties of exponential log equations or expressions. The first one, if this is in general, if log base b of bx, so if these two are the same, then this whole quantity equals x. The second part of this, if you have b to the log base b of x, so if these two are the same, then again this whole quantity just equals x. Okay, don't make these properties more difficult than they are. So in the first example, we have 9 to the log base 9 of 2. So because these two are the same, this whole quantity just equals 2. Minus, now we have log base 4 of 1/4. So what I do off to the side, I say log base 4 of 1/4 equals what? And then I change this to exponential form. So 4 to the what equals 1/4. Well, to make that 4 a fraction, that exponent would have to be a -1. So this is minus a -1, which is 3. On the second one, this is like the first. So these two are the same, these two are the same. This whole quantity equals 5. We have 3 to the log base 3 of 8. Again, this is 8, so this is equal to 13. And the last example, log, 7 to the log base 7 of 11, that whole thing equals 11, minus, now we need to simplify, log base 3 of 81. So log base 3 of 81 equals what? Change it to exponential, so 3 to the what equals 81, and 3 to the 4th equals 81, so that x is 4. So this is 11 minus 4, which is 7. The very last property is called the one-to-one property. So in general, if log base b of x equals log base b of y, then the arguments are the same. So if the bases are the same, then the arguments are equal. So in example A, notice that we have log base 2, log base 2. That means that the arguments are equal. So we would say 2x squared plus 8x minus 11 equals 2x plus 9. This is a quadratic, so we need everything to one side. I'll subtract the 2x and subtract the 9. So 2x squared plus 6x minus 20 equals 0. Let's try to factor this. So if I pull out a GCF, that's x squared plus 3x minus 10 equals 0. And I believe this will factor then to x plus 5, x minus 2. So our two solutions are -5 and 2. On the last example, again, notice we have log base 3, log base 3. So the arguments are equal, then we solve. If I subtract 2x, I'll have -x equals -4, and then x equals 4.